Next up, we have Claire Ozanne, who is going to talk to us about infrastructure as code. This is Claire's first time speaking, so she dared to be a speaker this year. So could you give her a huge welcome and support? So thank you very much, Claire. I'll let you take it away. Thank you.
Okay. So thanks very much for having me today. I'm Claire. I'm 28 years old. I'm from Belfast, currently working as an automation engineer in a law firm. And I didn't initially have a background in tech. I graduated with a degree in Russian. And 2 years later, I took a software development apprenticeship. And I've attended a lot of these types of talks, but as I said, never actually spoken at one. And I find that it can be that the person worst placed in the room to give the talk is the person standing at the front delivering the talk, which makes sense because if you're an expert and you're dealing with it every single day on a microscopic level, it's hard to take a step back and give a concise overview and make it make sense. And that's really what actually inspired me to give this talk was with DevOps. It's covered with a lot of jargon and buzzwords. It's really trendy at the moment, but no one actually really talks about what it actually is, and implementing the working practices in practical terms is actually a bit of an enigma. So let's get straight into it. What is DevOps? So I just Googled the definition and I got the combination of cultural philosophies, practices and tools that increases an organization's ability to deliver applications and services at a high velocity. Okay, so I don't doubt for a second that is an accurate definition of what DevOps is, but despite this, it hasn't really told us anything whatsoever. So let's just take the word, first of all, DevOps. So if we take the blend of dev, development, and ops, so ops being operations, which are the daily tasks, slightly boring tasks, dealing with data admin or dealing with questions from users, development being the software development side of things, we start to get a better understanding of what it actually is, and it's this collaborative environment. It's a blend of roles within one person, within one team, and then this leads to a more collaborative environment and also a sense of shared responsibility. So also when I Googled it, it came hand in hand with Scrum and Agile and Kanban, which are all really trendy buzzwords at the moment as well. And it's this idea of releasing a product iteratively. So for example, in the first sprint or the first session of work, you'd maybe get the minimum viable product out the door. And maybe it won't be good, it definitely won't be perfect, but every subsequent sprint, you're going to either improve it or add some additional functionality. Whereas previously in the past, what's known as the waterfall method is there would be siloed teams and several different siloed teams. It would take months and months to get the product finished. It would start with gathering the business requirements, going to design, then it would have a bit of front-end coding, back-end coding, some testing. Finally, it would be released, and by this point, maybe the business requirements have actually already changed. And the developers working on the project may have been contractors, and they've been contracted to go and work on another project, so they're not even there to really help maintain it or see how it's being used. So DevOps practices and releasing applications at this quick pace and high velocity has really led to a thirst for enterprises to adopt and start using cloud computing and cloud technology. So what is the cloud? Okay, so essentially it's just a server that is elsewhere. My personal background is in Azure, which is Microsoft's offering of the cloud. The other main competitor, which has a huge market share, is Amazon's offering, which is Amazon Web Services, AWS. GCP, Google Cloud Platform, is also got, it's actually really starting to take over. And there's even some underdogs coming in, for example, Alibaba, just coming from China and undercutting all the prices. There's a few like data privacy concerns surrounding it, but focusing today on Microsoft, but the concepts are the same with all cloud providers. So what Microsoft has done is they've already bought all the servers and all the computers, and they're hosted in these data centers around the world globally. So there's a few in each continent. And they are just basically huge factories just full of computers. And you're remotely accessing them just through your browser, through the internet. We're not paying upfront for the cost of the hardware. You're just leasing them off Microsoft for a monthly subscription. And you're only paying for them the amount of time that you use them. I'll just show you a quick picture. So this is what they look like in real life. So yeah, because of this, cloud computing is virtually instantaneous. You have a whole suite of Azure services and products at your fingertips that you can use immediately. There's no waiting for manufacturers, waiting for lead times for hardware. And it's really revolutionized the working practice in 3 ways. So first of all, developers need to have a much wider knowledge, maybe a slightly shallower knowledge, but a more broad scope of what it is they need to know. Or you could think of it that they need to know a lot about one thing, and that one thing is the cloud. And again, as I said, really fast-paced. Releases are going to be a lot quicker. But then point number 3, less bureaucracy. So there's less rules, less checkpoints into creating an application because it's all centralized and it's in just one place, and that is in the browser where you can manage your entire cloud estate. Okay, so this lack of bureaucracy and minimized checkpoints is given a lot more autonomy to developers. They have a lot more agency and freedom, and it's created a more libertarian workplace, which is great on one hand. It's really driving innovation and creativity, but there are several drawbacks to this. So the pricing subscription model, previously you would have paid for the hardware and then used it, and now you're just immediately using the hardware and paying for it at the end of the month. So you might have a nasty surprise when you rack up a huge bill and you get your subscription bill at the end of the month. Consistency within the business. So I'm talking here specifically about naming conventions. As an example, you might have 50 teams in your business and 25 of them have spun up a virtual machine and they've all called it VM1, and no one knows what belongs to who. And the other 25 have spun up one and called it Computer One, and they don't even use it. So it can get a bit messy. Security as well. If there's less checkpoints and less bureaucracy around this, or necessary bureaucracy, what's to stop someone from creating a SQL server, giving it public internet access, and the username is user1 and the password is password1, which has happened before, but that's a talk for another day. And finally, the legal side of things. So let's remember that these servers that we're using remotely are still physical servers. It's just that they're located elsewhere, which means that you have to respect the local jurisdictions of where that data center is. Germany, for example, has really strict GDPR rules. So if you're using a data center based there, you're going to not want to probably store much personally identifiable information there. And in just a few short clicks, I can show you how you're sitting at your computer, you're in the browser, you're at portal.azure.com, and you want to create a virtual machine, a machine that you can log into, potentially from a thin client. You're using it as a VDI, maybe you're using it to store data, or using it to host an application. I'm provisioning it now through the cloud, and I'm just adding a few specifications, some RAM, CPU, the OS flavor, and post-deployment, a template is created by Azure, a JSON format. This is called an Azure Resource Manager template, or an ARM template. It's taken all the parameters which I've entered in to the portal, to the Azure interface, and it's created a JSON object full of these parameters, which means that I can take this and then deploy the completely identical virtual machine again, or maybe I just want to change one parameter and have an almost identical machine that I can use. There's some pre-made templates in the portal. So this is an example of an ARM template here. It's written in what's called declarative syntax, which means I state what it is I intend to create, but I'm not actually writing any low-level programming commands which explain how it should be created or provisioned or built or added to the network. And this is actually something that the clever people at Microsoft have created, is this middle layer as your resource manager. So it's a layer of abstraction which takes the template and translates it into these programming commands which are needed in order to create the virtual machine. And that's great. That's all well and good if you want to have an exactly identical resource and you only want a few of them. But there are a few, it's a bit complicated, ARM templates. It's virtually impossible to build from scratch. No one wakes up and just is able to speak in JSON. It's quite complicated with the formatting, a lot of nested elements. You're not going to know exactly every parameter you need. And it's extremely verbose. So what Microsoft have done is actually gone and written their own language to simplify this. So in comes bicep. So you can see what they're doing here, bicep and arm. Bicep's the strongest part of the arm. So I'm using Visual Studio Code here, development environment, and I've installed a bicep extension, which means I can leverage the IntelliSense and have things sort of pre-filled and pre-populated given when I give prompts of what I want to create. And there's therefore minimal variables to change. The industry competitor is Terraform. There's also a few others, Ansible. Terraform's cloud agnostic, meaning you can use it with AWS, GCP, which has advantages in some ways. It's great. Bicep is Azure native, so it's going to be maintained and updated by Microsoft. But the beautiful thing about these templates, these are infrastructure as code templates, is you can save them as centralized repos in your business and have developers clone them and use them to provision virtual machines and resources as a self-service tool. And this is where we get the answers to the problems posed earlier of consistency, security, and legal issues. So saving your infrastructure specifications as code repository provides the guardrails of what is and what isn't, or what shouldn't be allowed. So, for example, for consistency, the parameters which are permitted can be populated and hard-coded or partly pre-filled in these templates. So, for example, going back to the idea of naming conventions, you could say every virtual machine has to have a prefix of the department you're in, 5-letter unique identifier, and then potentially the environment it's in, so dev or production. Only allowed specifications can be hard-coded in as well. So, for example, no public IPs on public net, or no publicly accessible IPs on the network, or something like that. Security as well. So, if you discover that your estate has been infected with some malware, you can quickly burn it all to the ground, delete it all, and then spin it back up again as you have the templates as a sort of backup of the infrastructure that is present within your enterprise. And infrastructure as code repositories in this way can be used, they're quite self-documenting. So if someone came to you in an audit and said, what are all the allowed virtual machine specifications in your company? You can say, well, here's our bicep code repo. And they say, okay, that's all well and good, but what was allowed back in 2021? And you can say, well, here's our repo from 2021 and all the times it was deployed. So it's not only self-documenting, but it's also going to actually provide version control for the company and for the business of what was allowed previously. So I went to a talk a few weeks ago about Terraform, and the speaker was talking about how to coerce developers into using it. And he said things like work with them from the beginning and find out from them what it is that they really want, make it easier for them to use these templates, these infrastructures, code repos, then going into the portal and creating it themselves. And in my experience, in large companies, that's a fairy tale. And if there's a way around it, colleagues are just going to go in and make their own, and it's still going to be like the lawless nature of the Wild West that we saw earlier. So to that, I say, just force them, make them use it. So how can we do that? So this brings me to my last point. So Azure policy is a service. Azure policy is a service in Azure, and it allows you to create these rules and enforce them at any scope that you want. So there's going to be a condition that might be met. So for example, every virtual machine created in this environment, and then it will have an effect, and the effect will be deny or audit, and this will actually deny someone from creating these kinds of virtual machines. And the beauty of these policies is that they can be assigned at any scope, but they can also have exemptions provided at lower levels down. So for example, if you apply a policy at a subscription level, this will be inherited by everything below this scope, but you could provide an exemption lower down for maybe a time delimited period. And so with that, the autonomy and the agency of the cloud can still be retained, but with significantly more control. Thank you.